I'll hold the class with some of the topics, which is about normalization. We have homework 6, which is about the normalization. And I'll talk about some of them, not all of them, some of them. Like I'm starting with the example of homework 6, number 3. So if you go your homework 6, then probably you'll find this example. In the homework, it's like this, like in the table way. But I'll talk about through a real invoice receipt, and all of the attributes are there. Why it's in this space? Because probably your next example, which is number 4, looks like this, like a big invoice number, and you have to figure from that invoice receipt that which is the what columns and in probably in final also you get in this way. So it's like one of the steps ahead, and this is I think a more little bit. So let's see. Now in normalization, probably through last class or last week's, he's talking about UNF, 1NF, 2NF, and 3NF, and BCNF. So I will try to help you to use this within this normalization form. First, UNF. UNF is nothing but U stands for unnormalization. So here, whatever you have, you don't have anything that you need to build up, or maybe you have to convert to. No calculation, nothing. Whatever you have in the given questions, you have to just put into the normal form and doing just simple nothing. For example, here it says pet ID, pet name, pet type, pet age, owner, within date, and procedure. So here everything is together. Only one difference is pet name, procedure, and amount. These three things within one parenthesis, just because those are, if you again look into this receipt, you'll see that pet name, procedure, and amount are in a same level. So first, when as a user I just got the receipt, for me, I know that invoice number stands for different things. Maybe the addresses are different for different things. Invoice ID number is for something. But when I'm seeing page, procedure, and amount, those are in the same level. Then as a user, I'm not expecting that which table that will go to or something like that. So this is the stage you have nothing to think. So that's why I put all of them in one parenthesis. So and probably when I studied the thing, I find that putting together 2 or 3 columns would be a good idea when for UNF, when you are supposed to convert them later on into 1NF. Then it will help you that, okay, fine, these 3 things are together. That means it's like address, like address, you have the apartment number, street name, and the city name, and the state name, and zip. Sometimes you'll see them together, separated by the comma or the space. And sometimes you're seeing them in a different column, like apartment number is a one column, city name is a different column. So if you put them together in a UNF level, then it will help you. It's like a trick, like it will help you in a next level. When I'm converting into 1NF, I really will understand that whatever was in together, I should not put them together. I need to do them separately. So if it's there, it's together, pet name, procedure, and amount. I just when I'm supposed to converting them into UNF to 1NF, I'm putting them in a different column with pet name, procedure, and amount, and the rest of the things will be remain same. And when I'm just differentiate them or grouping them, I just transfer the primary keys with them. So why pet ID is coming from? Because pet ID was chosen a key as because the pet name is a characteristic and not a good candidate key. So again, I would like to go back to our given example. Here you see that here's only the pet name. There's nothing called pet ID. But in UNF, I put them together, pet name and procedure and amount. But when in terms of doing the 1NF, I will feel like let's put a new primary key for pet, which is called pet ID. So it was not there. I put them with my own decision. So sometimes you need to have a new ID, or key to separate them. Again,
If you just put just the first key,
yes,
the answer will be wrong or correct?
like invoice number only.
Yeah.
That's not quite good enough, because still in a one invoice number you can have 2 or 3 paid names together. If you have more than one paid, then it's still the same.
Quick question. For question number 3, we had a visit date and a procedure. They are
Yes.
multi-valued attributes,
Yes.
right? So that's why it's not in the normal form.
Yes.
So does the visit date will be included in the primary key as well, since like the procedure will be dependent on the visit date, or we only have one primary key, which is the bit ID?
I think that ID will be a good idea. Visit date will be the candidate key
Right.
together.
Okay.
So-
that's what I mean.
Yeah.
Okay, nice.
So honestly, when I started studying these things, in my times also this time, I find at least 3 concepts needs to be much clear, not really transparently clear. If it's really 100% clear, you're a very good student. If it's not, still try to keep in your mind 3 things. One is like candidate key and primary key concept should be separate. It's not same thing, but the definition nearly same. And transitive dependency and full functional dependency. Those are like a term, but you have to remember through a example or something from Google or something like that.
Yeah.
So we'll be introduced with the rest of the topic for our next things like second 2NF or 3NF. So far we understand that from one normalization form to a 1NF, I need to separate them. I have another good example. So bad with this. I'm seeing these things in my laptop, but not here. What's the reason?
Is there like a mirror view?
Okay. Whatever my example is. So forget it. This is the only example. I would really like to write sometimes you can have like a multi-valued column. Like dress 1 is have red and blue together, separated by a comma, and dress 2 is having a separate values like yellow and white. But if it's the UNF, then for one NF, I will have one column called dress and another column can have color, and then I will there will be like repetitive values for the column called dress, because that will be like dress 1 will be for first red, and then dress 1 again will be for blue, and then dress 2 will be for yellow, and again dress 2 will be like for white. So when you are doing from UNF to 1NF, you can have repeating values. So for our next target, which is to NF, our main target is to remove the repetitive values. Here, when you're having invoice number and again having invoice number, and also paid ID for the first time, then you can realize that if I am now separating the paid ID and paid name for a different table, then there will be like a less repetitive values. As I'm saying here, if I'm having more than one paid, then still this table will have repeated values, right? Because paid ID will be different, but for the same invoice number, I'm having more than one value. For invoice number, it's getting repeated. Only seeing through the column names, it's so hard to understand the repeated names. But if you see through the data, then it's much easier. So if you, I think not everybody has laptop, so still I'm repeating here, like if I'm having paid name called Rover, and but paid ID is different, but whenever the invoice number can be same. So this is the one thing, and then for 3NF, I have, you can see one more thing called customer number, which was choose a key just because customer name is in a character string and not a good candidate key. So customer address was broken apart into 3NF for all foreign keys are identified. So again, it is here till 2NF, I'm having in first table customer name and customer address, these two, and customer name and customer address is not a good idea to having them always in a invoice number or invoice date, because one of the customer can come up with for second times and then within the same day. So the one customer can have two receipts at the same time. So if I take out the customer name and customer address from the first table, again I need some key. The way we choose paid ID as a new key. So when I'm separating the customer information from the first table, I need again a new ID called customer ID. So in 3NF, now I'm having one more problem is like customer address. So here when I'm having customer address, that is still the multi-value. So when I'm doing the 3NF, I'm just separating them in small things called street, city, and postcode. So everything the first question came into my mind when I used to study them, like how I should understand that I need to separate them, or maybe how I need to understand that I need to have a different ID called customer ID, or when I need to understand that my customer address needs to be distributed into small things. So these things are really, sometimes it's given, sometimes it's not given. Like here it's given just because I have the invoice with me. So when I'm seeing these things, customer name and then the address the way it is, so I understand that it needs to be grouped. But when you have not it's given, then you have to understand and you have to make by yourself. And for a final or maybe your homework when you're doing it, write your assumption that even if there's no invoice, say it's like this, then still you can tell that customer, I'm assuming customer address is having street, city, and zip code, or whatever your assumption is. Write that. So this is kind of one of the solution of your homework 6, number 3. Here, again, invoice number is coming from first table to second tables and also from paid table, the paid ID is going into the invoice paid. When so we know these things like when any primary key is going to the another table, then it becomes the foreign key. So you have to mention always the key that is coming from the another table. So in invoice table, invoice number is the primary key, but in invoice paid, the invoice number becomes the foreign key. So now you're having one more much complicated exercise, which is called shipping, and with the functional dependencies. So in previous example, we are assuming, and I'm not seeing any, I'm not saying anything which is functionally dependent with each other. But in this example, it's given that the functionally dependency is the sheet name is dependent on the sheet type. No, sorry. These things are completely means the reverse. Like when any of the arrows is coming from sheet name to sheet type, that means sheet type is depends on the sheet name. Please remember this because I always make that mess.
What's that again?
So like if A is arrow to the B, generally you feel like A is dependent into the B, but no. If the arrow is indicated into the B, that means B functionally dependent onto the A. So it's very confusing, but again, when the arrow is facing into whatever the object is, that object actually dependent on the object. So this is the dependent one. So when I'm saying sheet name, that means sheet type. Another thing is when you are having something not abstract like A, B, C, X, Y, Z, if you have something called meaningful, then you can also think in this way that if sheet type, how I realize that which type is what? By the sheet name, right? It's a big, like maybe some like small boat and very large boat or something like that. So by the name, we are understanding the category. So sheet type is having its own definition when it will have the sheet name. So when you have the arrow, always these things is functionally dependent on these things. So when I'm saying with ID, that means sheet name and cargo is dependent on the ID. Sheet name date is ID and port, that means ID and port is dependent on the name and date. So, and also when we are, these things also will have given to you as a task, like what you should do next. Identify the candidate keys, normalize to 2NF, and normalize to 3NF, and normalize to BCNF. So, by the functional dependency, this is our target now. So here, key is sheet name and sheet date. You can see like, again I'm saying, if it's not mentioning in your given questions, then you have to assume. And always write your assumption that it's not given, but my assumption is this and that. So that even if actually you're not correct, but by your assumption, probably you're getting some marks. So here it's assuming that key is the sheet name and the date. Now for 2NF, I'm doing shipping is a one table, and another is ships, and another is purchase. So for shipping, I'm doing that shipping name, ship types, and which ID and cargo and port date together. Why? Because here shipping name and shipping types and ID, by that functional dependency, I'm grouping them here as a date. So we have partial key dependency as ship name alone can determine the ship types. So we normalize into ship name and ship types. So again, as we had that things an arrow, right? So we put these two together in a separate tables as because they are having that functional dependency. And by the other functional dependency, I'm dividing into them as a wedges, so which takes the ship name from here and the ID from there and the cargo from here and port and date. So if I'm taking these two out of in a separate tables and rest of the things in a separate table, still I'm taking one of the candidate key here. So that means I'm assuming first that ship name and date is the primary key. So when two primary keys together, that means they are candidate key. So when I'm doing the 2NF, I should take one of the candidate key into the table which I'm dividing. For 3NF, where as 2NF wedges has transitive dependency on ship name, date, and the ID and the cargo together. So now I'm just before I was having these three tables. Now I'm having these three tables in a different way, which is still ship name and ship type are together, but the cargo is now a different tables. Here you were having a different tables called only the voyages, so ships and voyages. That too was your 2NF. But when you are doing for 3NF, then you are taking cargo out of it and putting a separate tables, which is called cargo, voyage ID, and cargo. Why? Why it is? Because just of their dependency. So if my dependency is given, then it's much easier for me to separate them into different three tables. So again, I'm repeating. That was my first 1NF. From my example, and in my example, dependency are given. So this is my first things, 1NF. Why it's not UNF? Because nothing is multi-valued. If something called address or maybe some valued are together, then still I need to do the UNF to 1NF. Here, I don't have anything multi-valued. So, I don't want to minimize that, then again it will go up. So, when it's UNF, do you have anybody in marker?
Yeah.
So when you have UNF, that means we'll have multi-values. So when you have unnormalization, that means you will have definitely one of the columns is multi-valued. So when I see something multi-valued, that means still it's not in a 1NF. So your answer should be not in 1NF. Then to do from UNF convert into 1NF will be putting the multi-value things in a different columns, say like this, red and blue together. Now I'll have a different column called color. And now I'm having red here and blue here. Whereas in UNF level, I was having like this, red, comma, blue. So it's a nice example, very silly. Multi-valued was like this, but now I'm having one of the column saying some colors. If have from previous, it will have a column name called color. Still, I'm continuing this, and I'm putting the things in a different rows. So my each and every row itself will unique, but in terms of other columns, it can be repeated. Now from 1NF to 2NF will be if any of the dependency is given. So from 1NF to 2NF, if any of the dependency is given, In terms of that, I will group all of the dependent values or columns into a one table and rest of the things in another table. For 2NF to 3NF, still if I'm having more dependencies, then I will continue from 2NF to 3NF in a different tables. Let's go to our example. So that was our first things, which is not UNF. It's in a 1NF already because there's no multiple column. But when I'm supposed to do it in a 2NF, then I'm doing this because our first functional dependency was shipping name and ship type together. So it's a good trick. I'm not so sure it's fixed rules or not, but it's a good trick when you are doing from 1NF to 2NF. Take the functional dependency serially. I mean, don't go by these things first and then this and this. Go serially, like which was the first functional dependencies given. When I'm doing from 1NF to 2NF, I'll take the first one first. And then for 2NF to 3NF, I'll go for rest of the dependency. I'll not jump into all of the dependency in first level. I'll go one by one, slowly. So by this dependency, I'm going to one table for first dependency, so separate tables, and rest of the things will in a separate table, but still one of the candidate key I'm taking or continuing. From the 2NF to 3NF, I'm ultimately converting from 2 tables into 3 tables. Sometimes can be 4 tables, but as my dependency was only 3, so I'm supposed to do in 3rd level, I'm supposed to do in 3 tables. So now you're having ship ports, which is having now 2 of the dependency together, and then rest of the 2 of the dependency when I'm separating them, then I'll have cargo and ships in a separate table. I hope it. Now for BCNF, let's look into the BCNF table first and into our 3NF table first. In our 3NF table, still we are having the ship ports where ship names and date, both of the candidate key are still there. So when I'm coming into here, then I'm trying to do basically the doing the ship name and date are together, but still I'm taking one of them out. So you are seeing these things. It's not functionally dependent with any of them because it's a different ID. This ID is completely functionally dependent on cargo tables. If you see that cargo things are dependent on the wedge ID directly. So I can do that. I can take out from these things from this table. So when you are in 3NF level, but you are supposed to do BCNF, that means you have to take out 1 or 2 attributes from your so far doing tables, but based on my dependency. So if you go into the BCNF, you will see that now I'm having wedge ID and ship names, and also wedge ID and cargo. So that means who are completely dependent on each other, they are separate tables compared to 3NF. So here, I was still having these things in there, but if wedge ID is dependent on ship name, so I can do them in a separate table, so that I'll have ship name, port and date in a one table, and ship name and wedge ID in a different table. Sometimes for me, it's so difficult to see them, to see the only column names and decide the things. Again, I'm repeating, it will be much easier if you are seeing in this way, where already the values are given. So when values are given, it's much easier to decide anything. Like, okay, if you are now having any ship names and cargo names, then it will be easier for you which is repeating and which is not repeating. So if you have tables with value, you're lucky enough. If you don't have, then you have to think or maybe assuming some data in that. Then it will be easier for you that which can be repeated, which cannot. So that is so far. I don't know your quiz will be taken or not. I have the solution. So quiz. So let's do the fetching. Oh, okay. So for you, in your student, yep. This is your number. So we are for your assignment. I'm already showing you the solution for number 3 and number 4. 3 was about the pet stuff, and 4 is about the ship. Now I will also again discuss one more, which is number 2. It's about the student. So you're maybe thinking like, okay, 3 of the things are given, so what I'm supposed to do? You're supposed to do still number 1 and number I have the whole solution. You're supposed to do the number 4 also, which is, sorry, 4, which is much more than the shape. You'll have like 4A, 4B or something like that. Yep. So that is so far. So we'll continue next person.
Let's go ahead.
One more example that I would like to discuss is student will have student ID, student name, student major, and student GPA, and there are transitive dependencies in these tables. Therefore, the tables is only in 2NF. It can be converted into 3NF and creating the column tables. So my target is to make them into 2NF first and 3NF, following by 3NF. So first thing is like when I'm having all of them together, then like your assignment is already been given with all of the columns together, which is student name, ID, major, department name, and all of them are together. So I'm supposed to do with the things with first 1NF, 2NF, and 3NF. So first I'm seeing here that a lot of the things, nothing is multi-value. So I can say that this is not UNF. This is already given by 1NF. So when I'm not having any kind of things are multi-valued, so I'm already into 1NF. So as we go by our rules, what is supposed to do from UNF to 1NF, if it's multi-valued, separating them into a different column.
So when you saw these, you don't, for example, don't just see, okay, you don't just look at the 3NF only.
Mm-hmm.
You have to first go to UNF, then go to 1NF. Like it's like a breakdown.
Yes.
You
Yes.
just don't, okay, we say so for 3NF, so just look at the balance for 3NF.
I don't think you will have something like already given in 3NF and you're supposed to do the BCNF. No.
No.
Probably you're having
Yeah.
something either UNF, which is not normalized at all. So either or it's already normalized in a 1NF form. Now you're start with from 1NF to 2NF. Probably this will be your starting point. So when I'm having all of them together and nothing is multi-valued, that means I'm in 1NF first. So what was my rule in for 2NF? It was like whenever from 1NF to 2NF, when I'm doing this, that means if I have any kind of functional dependencies which are being together. You remember on our first example, we are seeing the pet ID, pet name, procedure, and all of the amount work together, which is our first example. Yes. here I took the page name and here I took my paid, procedure and amount in a one table and rest of the things in another table. That was my first target. So that was like in UNF, when I'm having one NF, then I'm just separating them into them. So for 2NF, I'm just making a new ID, which will help me to make sure that paid is completely different, take out from that invoice underscore paid from into a different table called paid. So now,
her process may be different from yours. The reason is that there's no unique way to model this one. And also, as I said, if you believe you are a normal person, you can do up to third normal form. So actually, your thinking is already reached the third normal form. That is, but she just showed one of the way to normalize.
so for our student table, so now here it's given, so when we are having the student ID, student name measure, GPA, student hours and class and names together, and student major and department ID, you can take it out because the student major and department ID are tangibly dependent with each other. So I'm taking them in a separate table. Again, I'd like to mention our ship example that when they are dependent with each other, I'm taking them in separate tables. So now, if there is no dependency is given, then I have to assume, and I have to write my assumption clearly that I'm assuming that my major, student major and ID is completely dependent with each other, so I'm taking them out in a separate table. So for department tables, again, a department ID, department name, department phone number, and college number, which are dependent with each other in themselves, so they are become a separate tables. And also the advisor related all the information, which is advisor name, advisor office, advisor building, and phone and department ID. You will find them in a separate column in your given information, but you have to realize that those are really have linked with each other, so that should be in a separate tables, and which are completely dependent with themselves, they should be in a different tables. So that could be one solution for your number 2. So so far discussed we ship example, bet example, and student example. So you will have a little bit more lengthy example ahead in your homework. So I'm looking forward to see that. Thank you.
Any question?
Yes.
You can answer.
Yeah, sure.
So, first, I didn't. You see how you did the 1NF, the UNF 1NF, and you put into a table the relations. I didn't know you're supposed to do that. I thought you were supposed to have A, B is dependent A, and that's it. And then after that, then you do you just tell them what's the, then do the, I don't understand why you put into.
Do you understand what you are asking? So let me say, I know it's not easy the first time to understand what she explained, because that is true. Each one has the different thinking process. Somebody already, why do we need to do that? Because I already, from the invoice of the hospital, I already think the customer information and the invoice information sounds like yes, that's true. However, we are training ourselves, right? So we try to see the step by step. So if we, without understanding the theoretical approach, you can do some practical thing. But that is just a part of the same thing. When you encounter problem of the normalization or designing, so if you have such a basic fundamental and theory of the normalization or the concept of the designing, then you can easily solve the problem, or you can understand what you guys need to do and what the other guys solve the problem. Okay? So please try to understand as it is, then your way. I cannot say your way is wrong, but definitely is correct, but try to follow the general step, the standard step to understand the process. Okay? Any other question? Which means, So if I ask a question in your final exam, you guys can answer everything, right?
If I come to your office.
Today I didn't. I'm very sorry. I didn't keep my office hour. I have a guest for the engineering 400. Some of you guys are taking the course, so we have the final, the speaker. Actually, who is the Dr. Park, who is my friend during my PhD. Actually, we studied together in Texas. So he actually here to check whether my teaching is improved. Okay. But he asked me not to introduce himself. But anyway, I'm very sorry. But anytime the best way is you can email me just a question. Then why it's not coming? Oh yes. So definitely one more time. So I'm going to use the almost exactly almost not 100% the same, but almost the same as the example of the quiz. Okay, but even though I copy and paste some of the question to the final exam, usually average is just a 50 or 60. Believe me. So please try to understand. If you understand with your eye, I don't think that you can get enough credit. Please try to solve the problem and try the different ways. Then finally you can understand the process. And also, most of the time you don't follow the exactly same way of designing. Sometimes you can use, as I said, the ER modeling, the conceptual modeling. Then you can map to the relational model. Finally, you can get it. As I said, the problem is the rare case, right? The less than 5% case, you need to apply some BCNF or such the normalization process at that time. If you don't know about what is the normalization, so it's not easy to understand. Okay, so today we are going to continue the topic of the transaction processing. So what is a transaction?
It's a set of operations.
Set of operation is kind of a logical operation for what? User? How many users? Many users are doing what?
Retrieving data.
So what is the basic operation of the database?
Read and write.
Read and write, right? Then it's the same as what the operating system is doing. Also, what application program are doing. But most of the time, application depends on the operating system. So operating system need to provide something way of such a basic operation. So that is the reason there is the system code in operating system, read and write. Okay. Then what caused that? What caused the problem? What happened when multiple process, multi-user, multi-process access the read, write the data same time? Sometimes slow. What happened? So we have two processes. And we have the shared data. So think about we have the bulletin board. So bulletin board, we have the shared information. Anybody can update such a data. So he took out the memo and update like the form. Then what if the other user, the other student update it? Yes, it's possible. Also, you can, even though you do not take out, so let's see I see the 3. So I try to add up the 4, but somebody see the same number, but the decrease the number, it will be 2, something like that. What is the name of this kind of problem? Synchronization. Okay? That happened, exactly happened, the same thing in the database system. However, it's more important and the crucial in database system. In operating system, we use the critical section problem to solve that. So for the critical section problem, we can use some semaphore, log, or the operating, the instruction, whatever. Database is more important. So think about the stock market. Are you doing the trading? No? Me? No. Is there anyone who are doing the trading? No. You?
No.
No? But you'd rather for the life, but be careful. But what if anybody can update and modify the stock market price? Okay. and what the mortgage rate, what interest rate, okay? We cannot guarantee what is the correct one, right? What about the bidding system? What about the eBay, okay? So anybody can update it. You don't know who is who, right? Who update the last one. So that is the same problem. To address that problem, we are going to consider not the system call itself, the read and write, open and the close is the system level. It may have the instruction, but it's the system call will be the basic unit of the operation. But that's not enough because the database can update the many files at the same time, not at the same time, in one click, one operation. So to do that, we are going to consider a set of operation as the one unit. It's a logical unit. Physically, there are many operations, but logically, it's the one unit that is called transaction. So that is a transaction. So transaction is a logical unit, which means it may have the many operations inside it. Basically, a number of update and number of the read the data. Then, in database, we will call that is the concurrency control. So what is a concurrency control? So mostly the data, as I gave you the example of the SQL Server. Nowadays, SQL Server support multi-transaction system, which means that many users can access the data. Then at that time, can we guarantee? Can we keep the certain state of the data? Do you remember what is a database state?
Yeah, keep changing it.
Keep changing.
No, it stays the same.
What is a database state?
It stays the same.
Is an
Schema?
instance at a given of
Yes.
It is an instance at a given point of time.
Yes. It's at the certain point. So database schema structure plus data. That is a certain state. Okay. Then we need to guarantee database state for multiple users. That is a concurrency. So we need to keep the concurrency control. Why do we need such a concurrency control? What if, in other words, what if we do not have such a control? If we do not solve the synchronization problem, what will be the issue? So there are loss of data problem, temporary of data problem, incorrect summary problem. So from the title, it's not easy. So we will see the example of such a thing. So we have the transaction 2 for example. Okay, T1. So T1 does not mean only the read the data. It's a group of the operation. T2 also has the group of operation, but T1 and T2 share the same data. Yes, that's doable. That's usually happen. However, T1 decrease the number. At the same time, T2 increase the number. Okay, then we cannot guarantee the output. That is the loss of data problem. You need to lose the updated data, right? Because of the two transactions access the shared data. It's a similar, almost the same problem as the synchronization problem in operating system. And similarly, we have another temporary update problem. So that is, for example, T1 is read the data, okay, and decrease and write the data here. Write the data and read the data item X. And so, for example, in this case, so is it yours, Neymar? Can I use?
Yeah, you
Okay, thank you. So X is the, let's say it's a 10. And minus N is the 2. So it's supposed to be 8 and minus 2. So you can write the data 8. Then read the data item X. What is that?
B.
A plus N. Let's say N is 3. Then X will be 11. And write the data item 11. Then, not this time, read the data item X. What will be?
11.
11. However, it's supposed to be
8.
in the same transaction, it should be 8. That's the temporary update problem because it doesn't have any solution to address the problem of the synchronization. Okay, concurrency, there is no concurrency control. Okay, so another good example is that it's really happen in the real database. That is the incorrect summary problem. Not from this one. So let me give another example, simple example. So we have a very big employee. So suppose that you own the huge company, 1 million, 10 million, 10 millions of the employees. Okay, let's say 10 millions of employees. Each one has a salary information here. So you'd like to average salary, calculate, retrieve the average salary. For example, select the average salary from employee where the, let's say, group by, not group by, just average, all of them, okay? It may take a time, right? It's 10 millions of data and you need to average that.